Week 4 BU 631 readings, Project Management for Business Professionals. In this unit, we will examine more advanced topics related to the planning and operation of projects. These important project aspects become more critical as project size grows. Specifically, we will be examining how to measure and maintain project quality, how to evaluate and compensate for project risk, evaluate the procurement process within a project framework, and continue our discussion on project scheduling systems. Chapter 7, Project Quality, Communications, and Stakeholder Planning from Methods of IT Project Management, 4th edition, focuses on 3 essential areas in IT project planning: quality management, communications planning, and stakeholder engagement. Below is a detailed summary of each key section, written to be understandable for college students or professionals new to the field. Pushpin 1. Project Quality Planning. This section emphasizes that quality is more than just meeting technical requirements. It's about satisfying the customer's expectations and ensuring that the deliverables are fit for use. Key points. Cost of quality. COQ includes both conformance costs, like prevention and appraisal, and non-conformance costs, like rework and warranty claims. Quality metrics. Projects must define specific, measurable standards for quality. This may include defect rates, test pass percentages, or user satisfaction ratings. Tools. Techniques like Pareto charts, control charts, and root cause analysis are mentioned as tools to monitor and improve quality. Pushpin 2. Communications Planning. This section explains how crucial, clear, and timely communication is to project success. Key elements of a good communication plan. Stakeholder communication requirements, knowing who needs what information and when. Information distribution methods. This might include emails, meetings, dashboards, or project management tools. Escalation procedures. Define processes to follow if issues arise that cannot be solved at a team level. Tools highlighted. Responsibility assignment matrix. RAM a tool like the RACI chart to show roles in communications. Communications matrix. A chart that maps out what information needs to be shared, by whom, and how frequently. Pushpin 3. Stakeholder Engagement Planning. Projects rarely succeed without engaged stakeholders. This section covers how to identify and actively manage people or groups that have an interest or influence on the project. Steps in stakeholder planning. Identify stakeholders. Understand who is impacted or has influence, internal or external. Assess influence and interest. Stakeholders are categorized based on their power and level of interest. Engagement strategies. Different stakeholders may need different tactics. Some require constant updates, others only high-level information. Techniques. Stakeholder register. A tool to record each stakeholder's details and needs. Stakeholder Engagement Assessment Matrix tracks their current and desired levels of engagement. Magnifying glass tilted left diagrams and visuals. The Stakeholder Power/Interest Grid on page 14 helps map stakeholders visually. A communications matrix example, earlier in the chapter, shows how project managers can organize who needs to know what and when. Light bulb summary takeaway. This chapter reinforces the idea that technical success isn't enough. To truly manage an IT project effectively, you must define and manage quality. You must plan and control communications. You must continuously engage stakeholders. By doing so, project managers can increase trust, prevent misunderstandings, and deliver more successful outcomes. Chapter 4, Launching a Hybrid Project by Cynthia Snyder-Denisio, 2022. Blue Book Overview. This chapter explores how to effectively launch a hybrid project by using vision statements, project charters, and assumption logs. It focuses on best practices and introduces a case study involving a winery expansion project, Dionysus Winery, that combines predictive and adaptive approaches. Telescope vision statements, the project's North Star. A vision statement outlines the ideal future state once the project is complete. It should be brief, 1 to 2 sentences, compelling and motivating, memorable, future-focused. Example, Denver to Honolulu on a hot day, a memorable goal for the Boeing 777 project. The book also provides a template adapted from Jeffrey Moore for product-focused vision statements, including who the customer is, what the product does, and how it's different from competitors. Memo Project Charter, the formal start. A project charter formally authorizes the project and provides a high-level roadmap. It typically includes purpose and justification, why the project exists, high-level scope and requirements, objectives and success criteria, time, cost, scope, risks and budget, key stakeholders, project manager's authority, sponsor's role and approval criteria. Charters are especially useful in predictive projects and are often unchanged unless major scope shifts occur. Grapes Case Study, Dionysus Winery. The fictional Greek god wine group, GGWG, is expanding by buying and renovating an older winery and launching new services. Key deliverables include renovation of production and storage, construction of a hotel, restaurant, tasting room, development of a winery management system, launch of a wine club and grand opening event. Writing hand charter highlights. Budget, $9 million. Timeline, grand opening within 12 months. Risks, staff availability, permit delays, cost/availability of materials. Authority, project manager can lead teams and manage budget, but not hire/fire or make technical wine decisions. Sponsor, Tessa Berry, COO, is accountable for success. Clipboard assumptions and constraints. Since projects begin with limited information, assumptions must be made and recorded in an assumption log. These might include assumptions, e.g., available skilled labor, construction materials. Constraints, e.g., local compliance regulations. Example from Table 4-2, page 14. A1 skills assume local talent pool is sufficient. Status, pending. C1, regulatory compliance with Alcohol Beverage Control Board. Status, active. The assumption log is a living document, updated as new facts emerge. White heavy checkmark key takeaways. A compelling vision statement unifies and motivates the team. A detailed project charter sets expectations and authority from the start. Hybrid projects benefit from combining formal documents, predictive, with adaptive flexibility. Assumption logs help manage risk early by identifying uncertainties and constraints. Key terms. Assumption, something accepted as true for planning purposes. Constraint, a limiting factor, e.g., budget, regulations. Project charter, authorization, and high-level roadmap. Vision statement, short, powerful statement describing the end goal. Assumption log, document tracking assumptions and constraints. In this topic area, we have examined the idea of project quality, both how it is defined and controlled during a project life cycle. We have examined how project quality is related to both communications and expectations, as well as how quality is managed in a hybrid format. Methods of IT Project Management, 4th edition, Chapter 8, Project Risk Management Planning. Blue Book Chapter Overview. Chapter 8 focuses on project risk management planning, a crucial aspect of IT project management that helps teams identify, assess, and prepare for potential problems that might threaten project success. It covers key risk planning concepts, the risk management process, tools and techniques, and practical implementation strategies. Magnifying glass tilted left key concepts and definitions. Risk is defined as any uncertain event or condition that can have a positive or negative impact on project objectives. Risk management planning is the process of deciding how to approach, plan, and execute risk management activities throughout the project. The chapter distinguishes between known risks, anticipated issues, and unknown risks, unexpected issues, as well as positive risks, opportunities, and negative risks, threats. Counterclockwise arrows button the risk management process. The risk management process outlined in this chapter follows the PMBOK guide and includes these 6 steps. Plan risk management. Defines how to conduct risk management activities. Includes roles, responsibilities, budget, and timing. Often results in a risk management plan document. Identify risks. Involves brainstorming, interviews, checklists, and historical data. Risks are documented in a risk register, which logs all identified risks with descriptions and possible causes. Perform qualitative risk analysis. Prioritizes risks based on probability and impact using ranking techniques or matrices. Risks with high severity receive more attention and detailed plans. Perform quantitative risk analysis. Assigns numerical values to risk impact using methods like Monte Carlo simulation, decision tree analysis, and sensitivity analysis. Useful for large, complex, or costly projects. Plan risk responses. Strategies are developed for both threats and opportunities. Threats: avoid, transfer, mitigate, accept. Opportunities: exploit, share, enhance, accept. Includes developing contingency plans and fallback options. Monitor and control risks. Involves tracking identified risks, monitoring residual risks, identifying new risks, and evaluating effectiveness of responses throughout the project lifecycle. Toolbox tools and techniques. The chapter outlines tools such as risk probability and impact matrix, SWOT analysis, root cause analysis, risk breakdown structure, RBS, Monte Carlo simulations, expert judgment, and Delphi technique. Visual aids like the risk matrix diagrams seen on pages 3 to 5 help illustrate how risks are categorized and prioritized using likelihood and impact scales. Bar chart risk register and documentation. A key output of the process is the risk register, which includes risk ID, description, category, probability, impact, risk score, PXI, mitigation and contingency plans, risk owner. The chapter emphasizes that this document should be living, updated regularly as the project progresses. Light bulb practical advice. Risk planning should be iterative and part of regular status reporting. Communication is crucial. Teams must know who owns each risk. Cultural factors and organizational maturity affect how risks are identified and managed. The project manager plays a key role in setting the tone for proactive risk planning. Memo summary of takeaways. Risk management is about anticipating and preparing, not just reacting. Effective risk planning reduces uncertainty, improves decision-making, and helps projects stay on budget and schedule. Integrating qualitative and quantitative methods creates a balanced risk view. Documentation, e.g., risk register, risk plan, is key to transparency and control. Chapter 14, Planning for Risk from Hybrid Project Management by Cynthia Snyder-Denisio. Blue Book Chapter Summary, Planning for Risk. Cloud with Lightning Introduction to Risk Management. This chapter introduces the concept of risk in project management as the uncertainty associated with future events. Because projects are temporary and unique, they naturally involve more risk than ongoing operations. Importantly, not all risks are negative. While threats are negative risks, opportunities are risks with potential positive outcomes. Risk, an uncertain event that can impact the project positively or negatively. Threat, a risk with a negative outcome, e.g., supply chain delays. Opportunity, a risk with a positive outcome, e.g., acquiring discounted equipment. Issue, a current situation that may impact the project, e.g., discontinued materials. Impediment, anything that blocks team progress, often used in agile contexts. Risks are classified into known risks, anticipated based on current knowledge, e.g., delivery delays due to global supply issues. Unknown risks, unexpected and unforeseeable events, e.g., sudden disease outbreak in vineyards. Direct hit risk tolerance and thresholds. Every person or organization has a different tolerance for uncertainty, known as risk tolerance. Risk thresholds are specific levels of risk that, when exceeded, trigger a required response. These can apply to cost, schedule, or performance. For example, a 5% cost variance may call for monitoring. A 10% plus variance may require corrective action. Low thresholds equals more risk-averse organizations. Clipboard components of a risk management plan. A risk management plan is a critical document that outlines how risks will be handled throughout the project. It is tailored to each project size and complexity and includes 1. Roles and responsibilities. Specifies who is accountable for identifying, analyzing, and responding to risks. For example, in the Dionysus Winery project, the project manager oversees the risk process. Subject matter experts handle risk identification for their domains, e.g., construction, supply chain, staffing. 2. Funding. Allocates contingency funds for risk-related activities, e.g., 10% of the budget with controlled release. 3. Timing. Defines the schedule for risk reviews, e.g., bi-weekly meetings or more often near major milestones. 4. Risk categories. Uses frameworks to categorize risks. PESTLE, political, economic, social, technological, legal, environmental. VUCA, volatility, uncertainty, complexity, ambiguity. Project-specific, construction, regulatory, staffing, etc. 5. Probability and impact definitions. Risks are ranked by probability, very low, 0 to 10% to very high, 71 to 99%. Impact based on cost, schedule, and performance. Cost, greater than 20% over budget equals very high. Schedule. 2. Week delay on critical path equals very high. Performance. 1 or more features non-functional equals very high. Bar chart probability and impact matrix, PXI matrix. A 5x5 matrix is used to evaluate each risk by combining its probability and impact to determine a severity rating, low, medium, high. Visual indicators, color or shading, help stakeholders understand the risk landscape. Balanced matrix, equal number of low, medium, and high zones. Risk-averse matrix, skewed toward identifying more risks as high. Test tube sample risk management plan, Dionysus Winery. An example plan outlines stakeholder roles, risk categories, frequency of risk assessments, and use of the PXI matrix. It applies real project elements such as vineyard management, construction, and staffing. Memo key takeaways. Risk management is a continuous process from start to finish. Risks can be threats or opportunities. Risk tolerance and thresholds help teams decide when and how to act. The risk management plan ensures a shared understanding of how to manage uncertainty. Tools like PXI matrices help prioritize and respond to risks effectively. Chapter 15. Identifying and Prioritizing Risk by Cynthia Snyder-Denisio. Blue Book Chapter Summary: Identifying and Prioritizing Risk. Magnifying glass stilted left purpose of the chapter. This chapter provides a structured approach for identifying, analyzing, and prioritizing risks in hybrid project environments. The goal is to ensure project teams can anticipate potential threats and opportunities, evaluate their impact, and decide how to manage them effectively. Brain risk identification methods. The chapter outlines 7 key methods for risk identification. Brainstorming involves structured team exercises using categories, e.g., construction, regulatory, supply chain, staffing, to prompt ideas. A wall station method with sticky notes is described for collaborative input and organization. Interviews, conducted with stakeholders or experts to draw out potential concerns using open-ended questions like, "What risks concern you most?" Document analysis involves reviewing project plans for inconsistencies or omissions that might signal risk. Analogous analysis compares with previous projects using historical documents like risk registers and lessons learned. Assumptions and constraints review identifies risks by questioning if assumptions are valid or if constraints are too tight. Checklists, broad-based, high-level checklists are preferred to ensure thorough risk consideration. Risk breakdown structure. RBS organizes potential risks hierarchically by category and subcategory to help teams think systematically, e.g., under supply chain, breakdown by cost, schedule, and availability. Clipboard risk documentation. Risks should be recorded in a risk register using complete statements that include cause and effect. For example, the budget is at risk. Strong example: because security cameras are more expensive than expected, there is a risk we will exceed the budget. The chapter emphasizes separating management planning, risk management plan, from tracking documents, risk register. Bar chart risk analysis and prioritization. Probability and impact matrix. Risks are scored by multiplying probability by impact to calculate a risk score, then plotted on a matrix. Example, from Table 15 to NP, A supply chain issue delaying equipment has a high risk score. 5 probability times 5 time impact equals 25, plus others equals 45 total score. Additional risk parameters. Urgency, how quickly a response is needed. Proximity, how soon the risk may occur. Manageability, ease of managing the risk. Controllability, control over outcomes. Detectability, ease of identifying the occurrence. Connectivity, how interlinked it is with other risks. Impact on organizational strategy, how much it affects long-term goals. Bubble charts, pages 10 to 11 combine probability, impact, and urgency in one visualization. The size of the bubble represents urgency. Moneybag quantitative risk analysis. Expected monetary value, EMV. Calculates the weighted average cost of outcomes based on probabilities. Example: Bailey Brothers has a higher risk of rejection and greater cost, $36,000 EMV. Avery Architecture has a lower expected cost due to a higher approval rate, $34,500 EMV, making it the better option. Decision trees. A visual representation of EMV data. Shows branching decisions and associated risks/costs clearly, as illustrated in Figure 15, 3 on page 14. Receipt key takeaways. Risk management should involve everyone in the project. Risks must be clearly stated, analyzed, and prioritized using both qualitative and quantitative methods. Probability and impact scores, urgency, and EMV/decision trees help inform better decision-making. Key terms. Risk breakdown structure, RBS. Risk register. Expected monetary value, EMV. Decision tree analysis. Probability and impact matrix. Reducing risk from Hybrid Project Management by Cynthia Snyder-Denisio. Magnifying glass tilted left overview. This chapter explains how to go beyond identifying risks by actively implementing responses. It breaks down 5 major risk response strategies, covers the concept of risk-adjusted backlogs for agile/hybrid projects, and demonstrates how to calculate contingency and management reserves using real-world estimating methods. Hammer and wrench 5 risk response categories. Avoid. Eliminate the threat entirely. Methods. Remove uncertainty, e.g., more research, relax constraints, extend deadlines, or switch to a less risky deliverable. Note: avoidance can lead to secondary risks that also need to be tracked. Mitigate. Reduce the likelihood or impact of a risk. Examples: create prototypes, run extra tests, use backup systems. Transfer. Shift the risk to a third party, often through insurance. Vendor contracts. You're still accountable for results. May create vendor-related secondary risks. Escalate. Used when a risk is outside project scope or authority. Escalated to sponsor, PMO, program/product owners. Accept. No action unless the risk materializes. Passive. Deal with it if, when it happens. Active. Plan contingencies and define risk triggers or fallback plans. Bar chart risk register example. The risk register for Dionysus Winery, pages 5 to 6, shows how each risk is scored, probability times impact. Response strategies, e.g., mitigate by hiring experienced vendors. Adjusted scores after applying responses. An example of improving opportunity score through exploitation. Clipboard risk-adjusted backlog in Agile/hybrid. For Agile/hybrid projects, risks can be added to the product backlog. These are reprioritized each iteration. Example: pages 7 to 8 new tasks added to address architectural changes and system upgrades. Illustrated in Figure 16:1, page 8, showing tasks like develop backup interface map, test upgraded cloud environment, each with points and iteration placement. Money bag calculating reserve. 1. Contingency reserve. Built into the baseline budget/schedule. Used by PM to manage known risks. Rule of thumb: 10% for low risk, 50% for high risk. More accurate method: risk-adjusted estimates using beta distribution. Expected value equals O plus 4M plus P6 backslash text. Expected value equals backslash frac O plus 4M plus P6. Expected value equals 6O plus 4M plus P. Where O equals optimistic, M equals most likely, P equals pessimistic estimates. Example: Table 16, 3, and P. 10 work package A expected value equals $3,200. 2. Standard deviation and variance. Used to estimate confidence levels. 84% confidence equals expected value plus 1 standard deviation. See Figure 16, 2, and P11. Tip: use expected values for planning. Keep standard deviation as contingency reserve. Table 16, 4, and P12. 3. Management reserve. Not part of baseline. Covers unknown risks or unplanned in scope work. Usually held at PMO or portfolio level. Brain key takeaways. Apply a risk response strategy for each threat. Always consider secondary risks and track them. Use risk-adjusted backlog in Agile to proactively manage threats. Calculate realistic reserves using risk-adjusted estimates, not gut guesses. Manage to expected values, not just optimistic scenarios. Old key terms from the chapter. Risk avoidance/mitigation/transference/escalation/acceptance. Risk trigger, fallback plan, secondary risk. Contingency reserve, management reserve. Risk-adjusted backlog, beta distribution estimate. In this topic area, we have introduced and examined project risk. We have evaluated how risks can be determined, prioritized, mitigated, and planned for. We have identified several best practices used by successful project managers to successfully manage risk within complex projects. Methods of IT Project Management, 4th edition, Chapter 9, Project Procurement Planning. Blue Book Chapter 9, Project Procurement Planning, Detailed Summary. This chapter explores procurement planning as an essential process in project management, especially for IT projects. It explains the methods and steps involved in purchasing goods or services from outside suppliers to meet project goals. Below is a breakdown of the main concepts and key takeaways. Key concepts introduced. Procurement planning defined. The process of deciding what to procure, when, and how. Important when the project cannot internally produce everything it needs. Includes make or buy analysis, contract type selection, and risk assessment. Make or buy analysis. A strategic decision to produce in-house or purchase externally. Considerations include cost, capacity, expertise, schedule, and risks. A cost-benefit analysis is often used here. Contract types. Different contract types are selected based on the nature of the work and risk appetite. Fixed price, FP best when the scope is well defined. Buyer bears less risk. Cost reimbursable, CR good for uncertain scopes, more risk for buyer. Time and materials, T&M blends FP and CR, used when the deliverable is flexible or unclear. Procurement documents. Key documents include Request for Proposal, RFP. Request for Quotation, RFU. Statement of Work, SOW. These documents describe the needs and set the expectations for potential sellers. Clipboard Procurement Planning Process. The procurement planning process involves defining requirements, what the project needs in terms of products or services. Identifying potential vendors, shortlisting sellers based on ability, experience, and cost. Developing evaluation criteria, creating a scoring system to compare vendors. Creating procurement management plan, outlines how procurement will be managed through the life cycle. Wrench tools and techniques. The chapter discusses tools such as market research, expert judgment, meetings with stakeholders, standard templates for contracts and proposals. These are used to analyze the market, select the right procurement strategy, and make informed decisions. Speech balloon roles and responsibilities. The project manager is responsible for ensuring the procurement process aligns with the project goals and that contracts are clear and enforceable. Stakeholders help define requirements and participate in vendor selection. The procurement officer or department typically handles formal communication with vendors. Stop sign risks in procurement. Procurement introduces specific risks such as poorly defined scopes, legal liabilities, performance issues with vendors, cost overruns or delays due to contract mismanagement. The chapter emphasizes risk mitigation strategies such as performance incentives, penalties, and detailed SOWs. Bar chart example templates and tables from visuals. On pages 4 to 6, there are templates and tables demonstrating procurement decision-making tools, contract type comparisons, sample SOW structure. These visuals help clarify how different procurement strategies apply to IT projects. White heavy checkmark final takeaways. Procurement planning is not just about buying, it's about strategically deciding how external resources will help meet project goals. Choosing the right contract type and preparing clear documentation reduces risk. Involving stakeholders, doing market research, and using standardized tools helps improve decision-making. Procurement planning should be closely tied to the overall project plan to avoid delays and cost issues. In this topic area, we have examined project procurement processes. We have evaluated the types of projects and project stages that may necessitate procurement in order to meet project objectives. We have also identified potential risks in the procurement process and identified practices that can align procurement activities with project goals in mind. In this topic area, we will expand on our understanding of project scheduling methods to include more advanced schedules that can be used for complex or dynamic project types. We will examine how these schedules can be generated and employed for traditional and hybrid project frameworks. Hybrid Project Management, Chapter 8, Analyzing and Finalizing a Predictive Schedule, by Cynthia Snyder-Denisio. Blue Book Chapter Overview. This chapter guides project managers through the process of refining and finalizing a predictive project schedule in hybrid project environments. It emphasizes techniques for evaluating schedule integrity, resolving resource conflicts, identifying risk areas, and establishing a solid schedule baseline. Magnifying glass tilted left schedule analysis. 1. Convergence and divergence. Convergence occurs when multiple paths merge into a single task, like tasks A, B, and C all feeding into D. It introduces risk if any prior task is delayed. It holds up the entire schedule. Divergence is the opposite. One task leads to multiple parallel paths, like task E leading to F, G, and H. If the initial task delays, it stalls all dependent tasks. Visuals on pages 2 to 3 illustrate these concepts in both network and Gantt chart forms. The chapter encourages reducing these convergence/divergence points where possible. 2. Resource allocation. After assigning resources in scheduling software, you may discover overallocation, where team members are booked beyond capacity, e.g., greater than 40 hours per week. Solutions include resource smoothing, adjusts tasks within their float, preserving the critical path. Resource leveling, reallocates resources even if it changes the timeline. Figures on page 4 to 5 show before/after scenarios of leveling, including visual representation of balancing workloads over multiple weeks. Motorway critical path and float. 3. Critical path review. The critical path is the longest sequence of tasks that determines the project duration. Key evaluation points. Are any high-risk tasks on the path? Is the path logically defined with real deliverables? Are there near-critical paths that might become critical? Are convergence/divergence points increasing risk? Should you add a buffer? 4. Float analysis. Total float, how much a task can be delayed without affecting the project's finish. Free float, delay allowed without affecting successor tasks. Figures on pages 6 to 7 explain how to calculate float and show how float offers flexibility. Managers should look for tasks with high float and reassess them for missed dependencies or potential reallocation. Stopwatch finalizing the schedule. 5. Schedule compression. Techniques to reduce timeline without changing scope. Crashing, add resources, people, money. Examples. Bring in extra staff or work overtime. Pay for faster delivery, e.g., overnight shipping. Fast tracking, execute tasks in parallel instead of sequentially, e.g., start to start with lag. It can increase risk, so use carefully. 6. Buffers. Buffer, insert a time to protect delivery deadlines, especially at risky schedule points. Feeder buffer, place before a path merges into the critical path. Project buffer, time between scheduled end and actual delivery deadline. Page 11 includes Figure 8, 7, showing buffer placement on a Gantt chart. Tip, buffer is not equal to float is not equal to padding. Buffer, strategic and intentional. Float, naturally derived from the schedule. Padding, arbitrary and undisciplined. Straight ruler schedule baseline. 7. Baselining. Once the schedule is finalized, it becomes the baseline used to measure performance. A baseline should only change if significant issues/risk arise, performance variance becomes too wide, an approved change request is introduced. It becomes part of change control. Some PMs keep a high-level baseline but work from a more detailed working schedule. Brain summary of key terms. The chapter introduces essential scheduling terminology. Convergence, divergence, float, total/free, resource leveling/smoothing, schedule compression, crashing, fast tracking, buffers, feeder/project, and baselining. White heavy checkmark conclusion. This chapter emphasizes that analyzing and finalizing the schedule is more than just setting dates. It involves evaluating resource usage, minimizing risk, ensuring timeline feasibility, strategically compressing the timeline, protecting deliverables with buffers, formally locking down the plan with stakeholder approval. These actions are crucial to ensure successful project execution in a hybrid environment. Chapter 9. Adaptive and Hybrid Scheduling by Cynthia Snyder-Denisio. Blue Book Overview. This chapter explores adaptive and hybrid scheduling methods, comparing them with traditional predictive approaches. It highlights how teams can plan, track, and manage projects where the work is uncertain or evolving, such as in agile environments. It also introduces hybrid models that combine both predictive and adaptive scheduling. Counterclockwise arrows button adaptive scheduling. Key concepts. Adaptive work is used when scope evolves during the project. Rolling wave planning is essential. Only near-term work is planned in detail. There are 3 types of adaptive work. Incremental, add features over time. Iterative, rework based on feedback. Agile, based on Agile Manifesto principles. Iteration and release planning. Iteration, sprint a fixed time box, e.g. 2 weeks, where work is planned and delivered. Release plan, high-level plan of when features will be delivered. For example, in the Dionysus winery system, inventory management is the first minimum viable product, MVP, followed by winery functions, membership, and forecasting. Iteration planning process. Held before each iteration, except setup. Backlog items are discussed, clarified, and estimated. Results in a clear iteration plan. Review and retrospective. Teams demonstrate deliverables to stakeholders. Retrospective sessions improve future iterations. Clipboard task boards. Visual boards, Kanban/Scrum/task boards, are used to track status, to do, doing, done. Can be physical or digital. Useful in both iteration-based and flow-based scheduling. Flow-based scheduling doesn't use iterations. Work is pulled from backlog when resources become available. A flow master may replace the scrum master. Gear hybrid scheduling. Hybrid scheduling combines predictive and adaptive methods for flexibility and structure. 3 hybrid scheduling models. Predictive with releases and iterations. High-level predictive plan includes placeholders for releases. Detailed adaptive work managed separately, e.g. on task boards. Predictive with adaptive schedule inserted. Adaptive release and iteration plans are built and inserted into predictive schedules. Allows full visibility of both planning styles, as shown in Figure 9(5) on page 8. Adaptive then predictive. Early stages, e.g. product development, follow Agile. Later stages, e.g., packaging, marketing, use traditional planning. Dependencies in hybrid. Hybrid projects often struggle with balancing structure and flexibility. Communication is critical, e.g., wine club software must launch before the marketing campaign begins. Memo summary. Adaptive planning supports flexible scope using releases and iterations. Task boards help manage and visualize progress. Hybrid scheduling integrates agile and traditional methods to suit complex projects. Success in hybrid approaches depends on recognizing dependencies, ensuring communication, and tailoring the approach to project needs. Key terms. Iteration. Fixed duration of focused work, e.g., 2-week sprint. Release plan. High-level timeline of deliverables. Retrospective. Post-sprint review and improvement session. Task board. Visual work tracker. Hybrid scheduling, combination of predictive and adaptive planning. In this topic area, we have examined more complex scheduling practices that may be needed for some projects. These needs may be a function of project type, industry, or unique company needs. We have evaluated how to create both predictive and adaptive schedules, as well as how to manage their implementation.